You know, we ask AI to do some pretty incredible things, right? From creating stunning art to helping doctors spot diseases. But what if I told you that that same super advanced AI could fail? I mean, really fail at a task so simple a toddler could figure it out in seconds. Well, today we're diving into exactly why AI gets so lost sometimes and the amazing research that's teaching it to finally see the world the way we do.
Okay, so let's jump right in. We're going to start with a simple little puzzle that, well, it reveals this huge blind spot in even the smartest AIs out there. And this isn't just some minor bug. It's like a window into how these machines understand, or more importantly, misunderstand our world.
Okay, look at this. The request seems totally straightforward. Find the horse that the man with the yellow hat is riding. For us, that's easy, right? We get it in a split second. But when you feed this same simple sentence to a standard visual AI, it just breaks. It completely falls apart. And here's what happens. The AI fails. It might highlight the man, sure. It might find a horse somewhere in the image, but it cannot connect the two. It doesn't get the relationship, the idea of writing. And this isn't a small mistake. It's a huge red flag pointing to a really deep fundamental issue in how these systems are built.
So what is going on here? What's the deal with this confusion? Well, researchers have this great name for it. They call it the bag of objects problem. And honestly, it perfectly explains why these super smart systems can get so lost. The whole thing boils down to this concept called compositional reasoning. See, for us, a sentence has structure, it has meaning. We understand the relationships between words like riding, wearing, or to the left of. But for the AI, it often just sees a random pile of keywords. Okay, and this slide, this just lays it out perfectly. The human brain follows a logical sequence. Step 1, find the yellow hat. Step 2, find the man wearing that hat. And step 3, find the horse that specific man is riding. Simple. The AI, on the other hand, just sees a bag with the words horse, man, and yellow hat all jumbled up inside. It tries to find all of them at once and totally misses the crucial links between them. And the data? Well, the data doesn't lie. AI is great at spotting one thing. Ask it to find a cat, a car, no problem. Super high accuracy. But the second you add just one more layer of complexity, asking it to understand how two or more things are related, its performance just tanks. The more complex the request, the worse it gets. All right, so if the problem is that the AI just sees this jumbled mess, what if we could actually teach it to think in a sequence, in a logical chain, just like we do? That single question is what led to a really major breakthrough. So a team of researchers came up with this brilliant idea called CoT Referring, which stands for chain of thought referring. And the concept is so smart because it's so simple. Instead of letting the AI just guess, you force it to reason through the problem step by step, mimicking human logic before it's allowed to give an answer. And here's how it works in practice, going back to our original horse problem. Instead of making one big confused leap, the AI is trained to follow this exact chain. It thinks, okay, first I locate the yellow hat. Then I find the man wearing it. So the horse that man is riding must be the target. It builds the answer one logical piece at a time. You know, the researchers themselves just nailed it with this quote. The task demands sequential logic, while the models provide a single-shot answer. They saw this huge mismatch and set out to fix it. So how in the world did they actually build an AI that could learn this new way of thinking? Now, this wasn't just some quick fix. You can't just flip a switch for this. Teaching an AI how to reason like this meant completely rethinking how you train it, starting from the ground up with the data it learns from. It really came down to two major innovations. First, they had to create a huge brand new dataset filled with these chain of thought examples. And second, they built a whole new AI model called RefLM that was specifically designed to learn from this kind of step-by-step logic. And this is where it gets really cool. They essentially built a team of AIs to teach another AI. They set up this incredible pipeline where one AI breaks down a complex sentence into logical steps. Then another AI checks that logic to make sure it makes sense. A third AI actually finds those objects in the image. And a final AI does one last check to make sure everything is perfect. They did this over 20,000 times, creating this amazing masterclass in reasoning for their new RefLM model. Okay, so the big question. All this fancy training, this cool new model, did it actually work? Well, the results they published are pretty eye-opening.
And the answer is a pretty big yes. The new RefLM model, with all that chain of thought training, boosted performance by over 2.5% on these tough queries. Now, 2.5% might not sound like a huge number to you, but in the world of AI benchmarks, that's a really noticeable jump, especially when you're talking about the hardest possible tasks.
And when you look at their custom-built test, the story gets even clearer. ReLM with a new training method easily beats the other models. But here's the real clincher. Look at that middle row. That's the same ReLM model, but without the chain of thought training, and it barely improves. That's the proof. The reasoning process itself is the secret sauce.
But numbers are one thing. For me, the most convincing part is seeing it actually do the work. Here's another example from the research that would just completely break an older model because of all the spatial relationships.
Your typical AI it gets completely lost here. The concepts of far left of and in the wheelchair are too much. It's another bag of objects failure, and it just gives up.
But RefLM, it nails it. And here's the kicker. It actually explains its thought process. It says, first, locate the wheelchair, then find the guy in it. So the man to the left of that guy is, and then it correctly identifies him. It's not just spitting out an answer. It's showing its work. It's thinking out loud.
So you can see this is way bigger than just finding people in photos. This is a fundamental step, a foundational piece toward a future where AI can understand and interact with our world in a way that feels, well, truly human. I mean, just imagine the possibilities here. Robots that can follow complex, multi-step instructions, whether it's in a factory or in your kitchen. Accessibility tools that can describe a chaotic, busy street scene with perfect clarity for someone who's visually impaired. Creative tools that actually understand what you mean when you say, make the reflection in that tiny puddle just a little bit brighter. We are really getting close to building machines that can truly understand what we want and then do it. And all of this leaves us with a really powerful thought to end on. As we teach these machines not just to see objects, but to actually reason about what they're seeing, we're not just building smarter apps, we are fundamentally changing our relationship with technology. The question isn't just, what can AI do anymore? It's becoming, what will we do with an AI that can understand us perfectly?